Welcome Copenhagen. I'm really thrilled to be here and to tell a story about a little company from the Netherlands. And the track host already said that he didn't hear from it. Well, if you go to the Netherlands, then you'll not find a lot of people who hear from them either. And I'm going to tell you just about how that happened. Although we run one of the largest IoT instances for consumers in Europe. So just before we really run into to the deep dive, I'm going to give you a little overview of how the presentation today will look. First of all, I did a little bit an introduction about me and my co-speaker, and about the company that I work for. And after that, I'll dive into what the product is about. The product that we sell is called Tone. And after that, I will give the mic over to Freek, my co-presenter, and he will serve you the main cause of this morning about the challenges that we are facing when we really start to grow. And I'll be finishing up with some final thoughts, and I hope that it will spark off a lot of questions. So who are we? Well, first of all, I'm Michiel. I'm the CTO of Quby. And I'm going to tell just about what Quby kind of company is. And my co-presenter is Freek. Freek is a Java architect who has been working for more than 10 years in software development. Myself, I have a background in telecoms. I have been around. I was working for an internet service provider when IDSN, I don't know if people still can remember, that was the main way of having fast internet access. And later on, I worked for a mobile phone operator when GPRS and WAP was really the way of doing mobile internet. So we've gone quite far from now. And currently, I'm trying to shape IoT as a new challenge in internet-related technology. So why are we here? First of all, because Freek and I are kind of proud on what we've achieved last year, and we really want to share our experiences. We think we have some learnings that you can take away, but we're also here to learn from you guys, because the story will show that it's not nearly finished what we have begun. Then again, I hope on a really interactive discussion at the end. So then Quby, who are we? Quby was founded already in 2004 as Home Automation Europe by three, I might call them real geeks that wanted to solve a personal itch in their home. They wanted to have more comfort in their home, and they want to do that by automating stuff. And they founded the company, and they started a product, and from there on, the journey started, because the first product that they made was the home control box. I already told you they were geeks. They were trying to solve an itch in their home, and what they made was something that would fit their needs. So what you see here right now is the first product. I think it's from 2006, and it was what you would now call a smart home gateway. And the problem with this product was twofold. That was, first of all, that it was pretty complex, and that made it expensive. So the people that could afford it, they didn't have the time nor the enthusiasm to tinker with it. And the people that would want to tinker with it, they couldn't afford it. So that was one of the problems with the product itself. And there was also another problem, that is that as a small startup, if you sell physical stuff like this, then you have to get your marketing up and running, you have to get your logistics right, and you have to do a lot of stuff which as a small company is really hard to do. So they were a kind of a great idea, but the execution should really improve on a couple of points. And they started first of all on how then say that we could make a successful product, how could we then go to market with that? And they were thinking about energy companies. Energy companies are in a transition currently, and that was way then, it was future, but now you see it going. Sustainable energy, decentralized production changes energy companies from just your supplier of energy into a kind of a service company, and they were thinking that they could use some help with that. So one of the things that they come up with was to provide a product that provided energy insight for customers, and they had the idea that they could market a product like that through the channels that energy utility companies have. So what you hear right now, what you here see is a kind of a pilot product of a little screen that had a wireless connection to a smart meter, and that could give you insight in your energy usage. And there's actually there's a plug on the right, and then there's a USB a connector there. You could put it in a laptop, and then you could see all kinds of graphs. And one of the problems with this product was that energy companies were interested in providing a product like this, but consumers tend to lose interest after a couple of months. So in the beginning, you're really enthusiastic about what are you using and where can I improve, and then after 3 months to 6 months, it ends up in a drawer and you don't look around to it anymore. So combining the two concepts, like the smart home gateway and a kind of an insight tool, we came up with a kind of an improved version of that, and that is what is being around as our smart thermostat. So what we did is we looked for a place in the home where we could put this inside device, and to put it somewhere where it kept being noticed. And in Dutch homes, most of the Dutch families, they have a thermostat in the living room, and the idea was if we could replace that thermostat, then we could own a really prominent place in the living room, and that is just what we did. So what you see here right now is the smart thermostat that we have. It's a 7-inch touch screen with a color screen, and it gives you both insight in your energy usage, both your instantaneous usage and your historical energy usage, and it can also operate the central heating boiler. So how does it work in practice? If you look at the total setup, you see the display in the middle, and the display is also functioning as a smart home gateway. So it connects with a little adapter to your central heating boiler. The adapter is also used to inject the power into the device so that it's nicely floating and you don't need to have a wall outlet socket near your thermostat. And on the other hand, it has a wireless connection to another module which is placed in the metering cabinet and which you connect to your gas and your electricity meter. So we developed actually 2 analog sensors to do that. If you have still what we call a dumb meter, then you can put the analog sensor on top of the spinning disk, for instance, for the electricity meter. And we count rotations, and by counting rotations, we see how much energy you use. If you have a smart meter, we can directly interface with that one. So that is the basic setup, and there's been hardware that has been custom developed by our company, and we also write the embedded software that goes with it. So the setup on its own is, of course, not really what you would call a smart platform. So you connect your device with your Wi-Fi router, and that gives you a connection to the internet. And we can also connect with several additional accessories like Philips Hue lightings and smart plugs, and even we connect with smoke detectors where we can then ensure that we relay any alerts to your app on your mobile phone. So how do we do that? So if you look at the total setup, you see the in-home setup on the left with the displays that act as the gateway, and they make a connection into a software platform that we call the service center. And we actually use VPN concentrators to make a VPN tunnel from each and every device into our service center, and we use that as the main to create a secure bidirectional connection. But that is also causing one of the problems later on. Well, Freek will go about it. So by creating this bidirectional connection, the device can enhance its own functionality by accessing some additional services that we run in our central platform. And these services, they are for software upgrades, but also to provide weather updates on the weather widget, and also to provide some additional insight services as a compare function where you compare your energy with your energy uses of your friends or from similar households. So then this was a huge improvement in the product, and we also had a go-to-market strategy, and we did pilots with almost any energy company in the Netherlands, and after a while we had our first working partnership. One of the three main energy companies in the Netherlands, called Eneco, they were also really seeing and that they had to change from a classic utility into a service company, and they believed that our product could help them make that transformation. So we launched the product that you just saw on the previous slides in 2013, and in the last couple of years we've seen really a doubling in sold units every year. So last year we had 175,000 connected, and this year we project to end on 350,000 of those connected devices. That is a good start, but it is insufficient to have a sustainable business model for a company of the size that we have. We're currently about 150 employees, most of them writing software and designing the hardware. And we need between 1.5 and 2 million installed devices to be really profitable. So the idea was to not be doing that in the Netherlands only, but to expand abroad. And that's where basically the fun started, because in the last 3 years that I worked for the company, we've grown from 35 people to 150 people. And then if you read up on the story of Steve Blank about from startup to an enterprise, then you'll see that all kind of interesting dynamics start. You need to get an HR department, you need to formalize communications, because the coffee machine is not enough anymore. But there was also something that Steve Blank didn't tell us, because with the growing success of the product, we ran into a couple of challenges, problems, call it whatever you want, because the success killed our technology stack that we had. And that is basically the main part of the talk, and I'm happy to give over the mic to Freek, who will lead you to that.
Well, thank you. Is it on? Yep. Okay. Well, thank you. Good morning. So when I came in at Quby at the beginning of this year, in my first week, we saw the service center went down 3 times in 2 weeks. So I said, well, I am the omen of bad luck for Quby, but no, this was the main thing. This is the success problem we have. The number of devices kept growing, and the technology we had was built with a completely different purpose, mainly to survive. Quby started as a startup, and the main goal was to make sure that they could pay the salaries each month again and again. So you need to squeeze in what you can, and that means that the solution you built back then, well, nobody thought of, okay, we need to be able to get to 1 million tones. They did a big celebration when we were at 30,000. That was already a huge achievement. But the next year, it was already so much more. So we choose the Twitter fail whale as probably one of the most interesting examples of how technology cannot live up to the size of the success. And then we said, okay, well, we need to change something, but where do you start? Because everything is suddenly in flux. And what we're going to try to explain is what we had for a few challenges. What was the problem then for that specific challenge, and how we solved it. So the first thing we're going to discuss is, okay, our infrastructure. And our infrastructure was a private data center, and we did everything ourselves. We bought our own hardware. We installed it in the racks. We went there with the machine under our arms, put it in the rack, configured it, did the networking. We installed the databases. We managed the databases. We did the security patches. Well, everything. And that was the big paradigm shift we had to make there. Because if you want to do everything yourself, there are some issues. You can't scale this, otherwise you have to blow up the team. But the first thing was the time to market issue. Because if we want to grow, and when I came in, they told me, well, every week they bring in new hardware because the service center needs it. So there were people continuously busy with setting up the hardware and then driving back to the data center and installing it there. But if you need to grow with the ambition we have, that's not longer workable. Who of you guys know Puppet here? See some hands. Does anybody has in his production environment a fully puppetized solution? So everything is done, oh, one hand, a few hands. You guys are lucky, we are not that lucky. Which means that people still log into machines, make changes, forget to bring it back into the scripts or into anything, forget to report it to the other colleagues. And we got some issues, surprises in production. So we brought everything to acceptance, brought it over to production, and suddenly things failed. So we had also a predictability problem. So this is not going to scale. So the main idea of Michiel was, okay, we need to automate things. We need to automate as much as possible. But not just that, we shouldn't be the ones who automate everything ourselves. This is, of course, a mind shift, because we said, well, we do everything ourselves, and suddenly we need to change that. And we are still, the discussions are a bit less now, but we had a lot of discussions with everybody in the company about, well, public cloud, is it really the thing which you want to have? And we said, yes. We want a public cloud solution. And we chose Amazon. Main reason, well, it was the biggest platform in the world. We did some comparisons and we said, well, we're going for Amazon. So not only on the infrastructure level, we can now say we can spin up a machine in minutes. That's awesome. But you also said, okay, we take a look at the PaaS level. And on the PaaS level, we say, well, should we manage our own database? Should we set it up? Should we have our own key value store? Should we configure our own load balancers? And we say, no, absolutely not. Probably the guys at Amazon or the other big cloud providers are much cleverer, more clever in doing this. So we said, we're going to stand on the shoulder of giants, and we're going to leverage from the PaaS services they offer. With one remark, we want to be able to switch between clouds, which means we try to use open standards out there, like, and compare it also with the other platforms. Like a MySQL solution, in the end, RDS is a MySQL cluster. That is also offered by Google and by Azure. So that makes it easier for us. And we said, okay, if we set up a platform, we're going to use provisioning scripts to do that. And everything comes from a version management system. And nobody is allowed to log in to a single system anymore. That's not allowed. And when we did that, we were able to bring back a setup of a new environment because, Michiel already mentioned it, the international expansion, we got NG in as our second client. And there was one guy of the ops team who worked for 3 weeks frantically in setting up a new environment just for the field test. With this setup, we now are able to create a new environment, production ready, production grade immediately in 20 minutes on IaaS and PaaS level. And then we had one thing left here, because we had our applications. Lots of them are Java applications running in Tomcat containers. And we said, okay, these things were managed by the ops people. And no, we don't want to do it. That lifecycle management, we don't want to do it. Yeah, it must be high available, because when you start moving to the cloud, you see everything is high available and resilient if you use all these PaaS things. And we said, okay, we need to follow that mantra as well for our own applications. So we use Docker to create it in a container, and we set up a Mesos Marathon platform where we deploy all these things. So we now have that fully managed and controlled through the CloudFormation scripts and using a CI/CD pipeline. So that means we're going to do less work. This is a picture from a few weeks ago. And this is the ops team, and there are people from support who are also are listening. And this is their stand-up moment where they discuss the issues and problems they're facing and what they're working on. And this team, if you see it, it's quite a big team. But they were fully focused on keeping the Eneco environment, our biggest client, keeping it up and running. And they did it sort of quite well. But when we said, okay, if we bring in a new client, are we going to multiply that team to continue all the operational work? Though we have, of course, a cloud solution which requires less maintenance. But The other thing was with the operations teams that they did all the deployments for all the teams. So everything went to the operations team, and they did deployment and did the validation and did the checks. But people who do operations at the outside are no developers. So when something breaks, and it is on application level, well, then we have a bit of an issue. So we had some local heroes who were always there to help out. Okay, something breaks, and the ops people didn't know. So we depended on a lot of people, and it didn't work. So we said, we need to change this. And this is one of the famous things you probably know from Amazon, is that you build it, you run it. And we said to the teams, okay guys, if you build an application, if you add features, you are responsible also for it in production. So when something breaks there, you need to fix it. Which meant that the operation team were focusing on their core competencies, infrastructure and platform services. And that helped us a lot. But we said, okay, we are trying to create a solution for multiple utilities, like Eneco and Engie, and the ambition is much bigger, because in the end of next year, we want to be at 6 utilities already. So how are we going to make sure that we can monitor all these environments, all these production acceptance environments, in a way that it doesn't mean, okay, yeah, now I need to log into this, and I log out again, and I log in there. And that's why we say, okay, we want to use a solution which is external of the environment, and for that we use SysDig. And SysDig is a hub-and-spoke solution where you have a central monitoring solution from where we get all the information in and can see what's happening. And we use Slack where we get some reports. That's quite useful. We wanted to do the same thing also with the logging, so to have all the logging in one place to get a better way to maintain it. But that didn't work. We looked into SaaS solutions out there, but unfortunately the most SaaS solutions who cover logging, they don't have data centers in the European Union. And the quality of our log information contains too much personal data, and we are not allowed to move it abroad or outside the European Union. So for now, we have chosen a solution with Elasticsearch and Kibana. And, well, it says Logstats, but we use Fluentd. This is all great, but then still we had to think that, okay, how are the development teams moving their components over to an environment? And they will say they will use a standard CI/CD pipeline. So with this set up, the teams can now develop and run and maintain their applications. The ops team can make sure that all the environments are up and running. And the ops team has have a lot of time left to start improving the environments and improving the CI/CD solution. Yesterday morning, who saw the Grand Prix in Sepang? Yeah? Yeah, of course I'm Dutch, so I'm completely now into Red Bull. So we chose a Red Bull car. But a Formula One car is a unique thing. It's fully tailored for a single driver, and each track where it drives, it's modified to get to the best performance. And that's all nice, but we looked at ourselves, okay, are we a company who built a Formula One car? Or do we need something else? Because what we built so far was for a single tenant, Eneco, fully tailored, which meant that we aligned their business processes and implemented that in our solution. If you look at our database, you can see references to Eneco concepts and terms. So this is not going to work either. And we saw that when we created or introduced Engie as a new client, that people just made a branch in their version management system and started from that copy and implementing new things. So what we were left with was that are we now going to double the development team for each utility which we introduced to Quby? No, absolutely not. We said we want to create a factory which produces the solution and no longer create a custom-made product for a single utility. So how we do that is that we say, okay, each component which is created should be created in a tenant or utility agnostic way. And if we implement a process We do it once. On a version management level, that means that we have a single master from where we will create the components which we will deploy through the CI/CD pipeline to multiple versions of the Service Center. So, is this a multi-tenant solution? No. We created a multiple tenant solution. And with multiple tenant solution, we create per tenant its own environments, completely isolated from each other. Because also the tenants, the utilities say, well, we want to have our own environment and do not want to have things mixed with other utilities. But if you do that, you need to make sure that you have a lot of things which can differ per tenant or utility. And we don't want that, because the more variables you have per environment, times the number of environments, means the number of work you need to work on. And we don't want that. So we said, well, logically, we see the Service Center next as the core product. And the core product is always the same across all utilities. And on top of that, we offer premium services, which are, through provisioning scripts, are deployed to it. They're isolated from the rest of the solution, and they do not interfere. But there are some things on configuration and business rules and styling, like separate SSL certificates. We want to have different checks on the data which the utility sends in. Like a customer number is different per utility. So we say, okay, we need to isolate these changes across the environments in such a way that it stays manageable. And styling, we have a support portal, for instance, and, well, there is a logo of the tenant in there. And this is one of the biggest hurdles when we came to the scaling, because it is really, really difficult to maintain a lot of VPN connections. We have the tone display, and the tone display can request information from the Service Center, all these additional services we offer, but also share information. That was the easier part of this. But we also need to send commands to the tone. Like you have the mobile app, and in the mobile app you can say, well, set the thermostat to a certain temperature. So these commands need to go through a consumer router or firewall, and you cannot just get in. I earlier told you already about, when I started, about the issues with the environment that mainly had to do with the VPN. Most of the hardware which comes into the office is made specifically to manage more VPN connections. Because each week when we started, 3,000 more tone displays were connected to the solution. And once in a while, the hardware ran out of resources. So 50% of our data center is focused on VPN. And we have 2 people, 2 FTE, fully responsible for managing the VPN connections. But when something goes wrong at an ISP level, network glitch, and things start to reconnect, and that happened quite a lot, you get cascading failures because our tones try to get to a new VPN concentrator, and these are already overloaded in capacity, and we were able, or a network glitch was able to bring down the whole Service Center. And that was our main fail whale. So, problem, how are we going to solve this? We looked into the solution on the VPN. Are we going to replace it with a single other protocol or technique? The VPN was very important for us because we needed a secure and low latency solution and bidirectional. There are not many solutions out there. You could say, well, if you want to reach out to a display through a consumer firewall, you need to have a tunnel. VPN tunnel is a known technology, and an HTTP tunnel is the other one. Are we going for an HTTP tunnel then? No. Our infra guys, they were quite strong on this, and the ops people, don't do that, please, no. Figure out something else. We looked into MQTT. Because MQTT, that's the other solution, you can use a broker technology. So instead of you send something to the tone can subscribe to a topic in a broker. And that looked quite interesting. So what happens over the VPN connection, that's interesting to know. it doesn't matter how much data or connections are over a VPN connection. Maintaining that VPN connection open is the most difficult part of the VPN concentrator. It mainly has to do with the SSL. So it requires a lot of CPU and memory. But over that line, it's HTTP traffic. I said, okay, if we have the information we send from the tone and we have the information we request, that's all HTTP based, we change it into HTTPS. That is the same SSL security as we use for the VPN, which means that we have we have two problems solved already. So then you get to the problem where, okay, what broker technology to use? Well, if you heard a bit about IoT, then MQTT is one of the more famous protocols out there. And they say, well, it is good on energy consumption, and we're going to look into MQTT. So we we started with a long list and a literature study, and there were 15 different MQTT brokers in there. And from that list, we came down to 3. And those 3 were RabbitMQ from Pivotal, HiveMQ, and the AWS IoT solution. That's interesting. There are 2 products in there, and there's 1 managed solution. And we say, okay, if we don't have to manage it ourselves, it means less work for the teams. But the HiveMQ solution was quite interesting. The RabbitMQ solution, sorry to say, it didn't scale to the numbers we wanted. We say, okay, we've seen all the studies and the articles about how awesome it is. We want to see it to work. And that means we want to see the solution to actually handle 1 million connections. And that's what we did with HiveMQ. We created a setup in AWS with 20 JMeter nodes who generated 1.2 million connections. As you can see, the blue line. And the orange line shows you how many connections per second it builds up to. This setup, it has 3 HiveMQ nodes who handle this. And we are impressed. HiveMQ, already from literature studies, showed that it is the best implemented MQTT broker out there. And it's quite a piece of engineering if you see this, that just 3 of these brokers are able to handle so much connections. But there's also a downside to it, because it means you need to run these brokers in Amazon and manage them yourselves. Okay, that's something we start to do some calculations. How many people do we need to manage this then? Because in the end, it's also about money. The main problem was with HiveMQ on the licensing, because you pay for each instance you run. And the license and support cost meant that you have a pay for what you pay for what you need instead of a pay for what you use scheme. That meant that we could not mix HiveMQ with other technologies. Thus earlier I said, okay, we try to split the problem into 3 parts. With HiveMQ we say, well, we do all traffic over a single solution, HiveMQ. Okay, we can work with that. We did the calculations, we looked at the number of messages and the data traffic, and we came to an amount a month what it would cost us. And we translate that back to what it costs per display, because we don't get that much money per display. So we need to be really careful on the economics of this. But how we do the multi-tenancy, or the multiple tenancy, is also an issue, because each time we set up a new environment, it means you buy a new license for HiveMQ. And they don't have consolidated billing, which is also a problem. So we said, okay, we look at AWS. And with AWS, we did the same test. What you see here is, by the way, the graphing solution for which Amazon has internally. Because our first test which we did, we got into some problems with reaching up to the number of connections. That all has to do with a limit set by Amazon to prevent you from, burn down a credit card. Because normally, this is not a case which happens that often. That you build up to 1.2 million connections, the green line, with about 1,100 connections per second. But we were quite impressed also about what Amazon had to offer. It's almost linearly. What you see in the test, by the way, is we started testing with a lower number of connections per second, and we said, oh, well, we can easily manage it. The people from Amazon said, okay, well, let's restart. Just create more connections. So the second time we did it again, it was short. Okay, sorry, please stop, we can handle more. And that, in the end, was the third attempt, which meant if we have our current data center, our solution for Eneco, and it goes down, it takes us about 25 minutes to reconnect everything. On Amazon, we can do the same in less than 4 minutes to reconnect the complete data center. So this is not an end-of-world scenario, but let's say this is the Amsterdam Internet Exchange, which connects all internet in Holland. That one goes down. Okay, corner case, but it could easily manage it. So, and then we came to the question, okay, what are we going to do? We have a solution which, from a technology point of view, Hive-MQ, it's awesome, fully implemented spec, but the cost level is too high. We looked at Amazon, and when we do all traffic over Amazon, Amazon will love us because we will spend $15 billion a month. So we said to Amazon, guys, you do IoT. IoT, awesome, lots of devices, sharing event data and streams and whatever, and you charge us $5 per 1 million messages. Sorry, your business model is not correct. And they said, So they advised to look into a mix of IoT with other things. And in the end, we had to choose for that specific solution. So we sacrificed on functionality in order to have a managed solution which is more cost efficient. Because you pay for each message you send. Which means on Hive-MQ, our starting cost for a new tenant was already €2,500 higher per month than Amazon. Because Amazon, zero. So these were some of the main challenges we had regarding scaling up our solution, both in multiple clients as in the number of connections per client. And then we get to an interesting question, which Michiel tries to answer. Because what makes scaling IoT so different from having a Pokemon Go app with a backend, which also scales in the millions? So Michiel, back to you.
Yeah, thank you, Freek. I hope you have a little bit more insight in what the challenges are that we are facing on the central software side, because I can take more than an hour also to give you more insight in the hardware development and how you get software to 300,000 devices that you can't lose because you can't send a USB key to ask a customer to fix it up. But from the central software side, what makes IoT different from your normal web app? And that's, first of all, is device management. Freek spent the last 5 minutes of his part of the talk on the connection problem and keeping a low latency connection between the device and your central platform, and that is really one of the key things that you need to solve. And another thing is that because of the large number of devices, specifically with respect to the number of customers that you have, the setup tends to be more complicated. And since we are in consumer electronics, customers are, because of the mobile app development with the freemium model, they are not willing to pay large amounts of money in recurring service fees. So we have to be really economic in where we spend our money. And in Eneco, the company that sells stone in the Netherlands, they ask €3.50 per month as a subscription model, and customers really demand ongoing innovation for that. So we tend to have the investment on improving the functionality, and we don't want to spend it on infrastructure. So we really need to think carefully about what kind of solution you take there. And then, as a last giveaway, the combination of having hardware with embedded software, with having centralized software running in the cloud and with mobile apps gives you, for a company the size of Quby, really a challenge in managing all the different technologies and the protocols. So that is one of the things that we're struggling with as well. So as a last overall conclusion is that we are well on the way, and we solved quite some of the hurdles that we have. But we also see that Internet of Things is not ready yet. It's heavily in development, and just as in mobile development you see every 3 months a new JavaScript framework popping up, you see with IoT that also developments go really fast. But there's one little subtle difference, and it is that developments that happen on a scale with these large amounts of little devices in your home, you cannot easily change every 3 months your protocol between your gateway and between the data centers. So one of the real big challenges that we still face is how to ensure that we can, with such a complex environment, we can be agile and we can change fast enough to keep up with all these ongoing developments. So that is on the message that I want to give away to you.
Very good. Thank you, guys. Let's give them a hand. All right, we have a good 10 minutes for some questions, clarification points. Anyone? While you think about your, we got a lot of good questions. I'll walk to the end. A quick question while I walk up there. Have you guys solved who owns the data?
Yes, we did, because it's the customer. It's the customer who owns the data.
So this was never a problem?
Well, no. There are ongoing discussions because of the economics that we try to increase revenues, and there you have some interesting opportunities also to resell insights that you can get from the data. So there's always a kind of finding a balance between what you collect on data, where you can use it for, but we use actually 3 principles there. There's first of all that the customer owns its data, and we cannot do anything with that data without asking for explicit consent of that customer. And then the second thing is that whatever you do with it, you need to be transparent about it, so you tell what you collect and what you use it for. And then the third is what we call in Dutch, voor wat hoort wat. In English it's translates like give a little, take a little. That is that customers are only willing to share the data if there's something in it for them as well. So you always have to have a clear proposition, and if you do that, then customers are willing to share data.
Yeah, I would like to ask, how do you ensure continued quality when parts of your sensors are provided by third parties, like you had the Philips Hue and you have Z-Wave technology?
I don't exactly understand what exactly your question you want to... Because what we do is when we integrate certain technologies from third parties into our solution, we do a thorough quality assurance there. So we have Z-Wave as the wireless technology between our own in-house developed components, and we do thorough testing there, and we also work together with the suppliers to improve the technology. The Philips Hue use case, it's just we use their API and we do kind of an integration with that. So there's a level of a difference between those two.
Okay, I'm also thinking very much about end users may not follow the update patterns that the suppliers encourage them to. I'm thinking, do you ask your end users to update in a specific pattern, or do your system actually help them update all their third-party appliances?
That's actually an interesting question you make here, because we have internally ongoing discussions about that. What we consider is that the smart thermostat is actually kind of mission critical in your home, because it connects to one of the most money-burning appliances in your home. And you can actually cause physical damage if you don't operate that well. So what we do is, up until now, we've always had a manually started software updates on the device to ensure that at least somebody's home when the software changes. That causes some challenges as well, because you have to have participation of your end users to get the software upgraded there. So there is a kind of a balance. But up until now, we see that our customers fairly quickly apply those updates. You get a notification on the screen, and from there it's 3 clicks on the screen to get it going. And about 60% will do the update in the first 2 weeks after we release a new version.
One more question from over here. Thank you. And don't forget to vote, by the way, if you haven't done it.
Hi, I would like to ask if you created your own interface to show the statistic like you show it, or just you have mobile application and desktop version of the service for the final users?
Well, initially, when the company started, there were no well-established standards out there. So what we did is we have our own protocol and our own interface. It's loosely based on UPnP. That has evolved over time, and we're now currently considering to see whether we can hook up to one of the more emerging standards. But that is typically something which has to do with this slide here. That is that if you are going to try to replace your own custom-built solution, which you want to do, because I don't want to invent protocols for inter-device communication. We want to let people have a comfortable home and help them to conserve energy. And if you then want to replace it, and you look what the different flavors and competitors are in there, then it's really hard to make a choice. So one of the main drivers there is that whatever choice you make, you should be able to somehow rip it out again and replace it by something different in a couple of years.
One more question.
Did you manage to solve the customers losing interest to device? Because I think placing it in the front room, still, we're getting very easily used to the things in our front rooms. Did it work?
Partly. Because what we see is that still people tend to lose interest if you don't engage them actively. So it is now the first year that they are really active, and then you have a full cycle, and then people, they start to believe it. So we tend to innovate on the product and use all kinds of additional services to keep the interaction going. So one of the things that you saw is that the weather widget that was not initially there, and we asked customers, would you expect to have weather on your thermostat? And everybody said, no, we don't, because if I want to know the weather, I get my mobile phone, and then it's very easily. And then we did some experimentation, and we saw that the interaction level doubles if you put the weather there. So people say we don't need it, and still they get twice as much to the display when we implemented that. So this is one example. Another example is that we're going to implement very soon a monthly report where you again get kind of summary of what happened in your home. So we're kind of evolving all kinds of initiatives there.
I have a bit of a follow-up question from the who owns your data that was asked before. And a little bit of a hook into the widget thing as well. Do you have an open API where either third parties or consumers themselves can get their stuff and maybe have their own widget for a doorbell that they purchased completely separate from you even knowing? Do you have like ideas to let others integrate into your product like that? Like over Z-Wave or something else?
Yeah, we do have our own API, but currently that's limited to the interface between the mobile apps and our service center. We are experimenting with 2 other kinds of interfaces that we could use to extend the ecosystem. And first of all, that's the Z-Wave interface, and to ensure that that you can actually become a real smart gateway, and also enable the connection of devices that are not really tightly coupled to our proposition. There are some challenges there because of the lack of standardization, and because Z-Wave is quite standardized already, better than protocols like Zigbee, but still you see that if you have a wireless switch, for instance, then there are some extensions there that you still need to then support by doing custom development. And the other additional interface is indeed to opening up also the user interface to install additional widgets. The current version of our hardware is so tight that we consider it unmanageable to ensure that you will have a kind of a sandbox where you can open it up to third-party developers, but also ensure that you cannot build a widget that kills the thermostat functionality, for instance. So we're looking into there, but we think that we need to, we can only actually get that live when we have new generations of more powerful hardware.
All right. Thank you, guys. That actually wraps it up. One hand of applause to the guys.